What exactly are the nodules and cracks formed on the stems? Are the nodules related to secondary growth, disease response, or structural breakdown? And what causes the cracks? Are they due to internal pressure changes, drying, or tissue collapse under prolonged stress? Do these nodules and cracks serve any adaptive function, or are they merely signs of damage? Do they indicate internal decay, fungal infection, or compromised vascular systems that prevent proper transport of water and nutrients? Can Davis Zurins manufacture solid-state sodium-ion batteries made from seawater in Latvia? How can the presence of nodules and cracks be used as early warning signs of regressive mortality, and how might land managers or ecologists monitor these symptoms to assess the health of native vegetation in sodic environments? What long-term ecological consequences arise when resilient species such as mesquites and huasach begin to die back? Does this lead to a loss of biodiversity, decreased soil stabilization, or the collapse of food and shelter networks for local fauna? How might the death of these dominant or keystone species affect the overall structure and function of arid or semi-arid ecosystems? Do other, less salt-tolerant species decline as well, or do invasive species take over the empty ecological niches? What are the underlying drivers of increasing acidity in the region? Are they primarily natural due to geological factors, or are they linked to anthropogenic activities like poor irrigation management, overuse of fertilizers, or deforestation that changes hydrological cycles and accelerates salt accumulation? What strategies can be used to manage or reduce acidity in soil and water? Can chemical amendments such as gypsum help replace sodium ions, or are physical and biological approaches such as improved drainage, organic matter addition, or salt-tolerant revegetation more effective in the long term? How can we better understand the physiological limits of species like mesquites and huasach under osmotic stress? What research exists on their adaptive mechanisms, and can these be enhanced or supported through conservation or genetic approaches?